You will recall in our cell story that the body has trillions of cells. Each one of these cells is a tiny factory making proteins, peptides, and enzymes to further its function and the function of that particular group of cells. In some cases, some of those proteins and peptides are sent on their way in the bloodstream to other cells. These attach to receptors on their surface to tell those other cells to carry out a particular action. You will also recall that all of those cells need energy produced by the oxidation of glucose in the mitochondria in order to function. Unfortunately, as you now know, that energy production produces toxic waste which damages the cells and its components. Damage is minimized by antioxidants which cells make and antioxidants from our diet, but not all damage is prevented, so repair is required. In much the same way, our factory, making goods and materials for our everyday lives, tries to minimize damage at source as the machines work away, but repair is eventually required, so a call is made to the maintenance crew, which comes in and fixes things. In our body, there is a special organ at the base of the brain called the pituitary gland. The specialized cells in this particular organ produce several different proteins and peptides, which it sends around the body to perform specific functions for other organs, and in some cases, all of the body's cells. One of these proteins is growth hormone, or GH. Whether it be human, dog, cat, or horse growth hormone, all mammals have it, and it performs the same function in all of them. We used to think that growth hormone was only required until age 18 or so to promote cell growth and maturity. We were wrong. In the middle of the 20th century, it was discovered that growth hormone continued to play a vital role throughout life. That role is cell regeneration and repair, and without growth hormone at optimal levels, we age prematurely and die younger. Growth hormone, along with its close companion, insulin-like growth factor 1, or IGF-1, is a signaling protein. Signaling proteins attach to receptors on cells and signal, or tell, the cell to do something. Growth hormone, once released into the circulation, has a short life. Half-life is about 20 minutes. So it needs some help to signal away all day for cells to regenerate and repair. Growth hormone acts on all cells to signal regeneration and repair, but on liver cells in particular, it signals those cells to release IGF-1, its day-long helper. IGF-1 has a much longer half-life, about 22 hours, so it is HGH's collaborator in signaling all of our cells to grow if we are young and regenerate and repair at all ages. So you can see that a deficiency of growth hormone leads to a deficiency of IGF-1 and a lack of that essential repair function to fix the damage done by free radicals in our cells, the damage that was left over after the antioxidants have done their best work to prevent it. Growth hormone levels are at their highest in our late teens and early 20s. After about age 25, those levels decline at a rate of about 14% per decade, or 1 to 2% per year. A result of this is that our ability to repair cell damage declines with age, and part of the aging process is this inability to repair cell damage as well as we could when we were young. This brings us to the question of whether or not we could improve our growth hormone levels to help our cells and enhance the way our cells recover from the continued assault from free radicals, radiation, sunlight, and other factors. There are some natural ways to do this. Exercise and a high-protein diet can bolster levels somewhat, and athletes take advantage of this. Growth hormone injections, of course, will elevate levels, but are only approved for individuals with proven growth hormone deficiency, and there are risks to their use in normally aging individuals, as it is too easy to push the levels of GH beyond the normal maximum levels for an individual. The body is clever. There are all kinds of feedback loops to prevent a variety of hormones and other essential elements and compounds from getting too high or too low. Above the pituitary gland in the brain, and controlling it, is another area of the brain, the hypothalamus. The hypothalamus monitors growth hormone levels, and through another hormone, somatostatin, puts the brakes on growth hormone production or allows more of it to be released. The hypothalamus constantly monitors growth hormone and IGF-1 levels, allowing growth hormone release when needed. In men, this release tends to occur maximally about 90 minutes after falling asleep. Women get a spike then too, but also release growth hormone throughout the day, more so than men. There are a variety of theories on why the sex difference, which we can review another time. Needless to say, the whole HGH IGF-1 situation is a beautiful symphony where each of the players contribute to ensure things work as they should. Earlier we noted that HGH levels and as a consequence IGF-1 levels decline as we age. Cell repair and regeneration suffer as a result. If we could bring those levels up again, closer to where they were when we were younger, we could improve our body's ability to repair. We also noted that there are some natural, and indeed some less natural but potentially dangerous, ways to do this. Stimulating the pituitary gland to produce a bit more would keep the feedback loops in play, as the levels would not go beyond the normal, as the brakes would go on if that were to occur. Those higher levels, however, could help to restore some of the better repair and regeneration of our youth. Can this be done? Well, yes it can. A particular combination of free-form crystalline amino acids can increase growth hormone and thereby IGF-1 levels, yet maintain them within the physiological norms for that individual by using the body's natural feedback mechanisms. A winning situation. Amino acids, as the building blocks of protein and therefore life, are safe and easy to take on a regular basis. These amino acids can help us with improved aging by improving HGH levels and therefore cell repair and regeneration. This also applies to recovery after exercise and other instances where the body is damaged from accident or injury. In our next chapter, we will show you how they go to work and how you too can benefit.